Welcome back to this architectural series on follower reads. There are two types of follower reads: strong follower reads, which are reads against global tables, and there are stale reads, which are what we're going to be talking about today. They're sometimes called as of system time AOST queries or time travel queries. We'll be looking at stale reads, and within that branch, there are two types of stale reads. There's exact time stale reads, which are when you provide an as of system time specific time to you, for example, minus 10 seconds. And then there's bounded staleness reads, which are calculated by CockroachDB. It's usually around 4.2 seconds. In this video, I hope to accompany the fantastic Cockroach University series on follower reads. Find a link to those videos in the description. Today, we'll look specifically at the effects of follower reads against a database that's receiving both read and write traffic. I have two clients. The write client will connect to the database and then we'll insert into a salary table a company, a state, a title, and a salary. The states I'm using are simply a collection of 3 states. I've purposely kept that small because that will encourage contention between the values. The larger the state collection, the less likely reads and writes are going to be requesting the same data, and the lower the contention risk. But I want to see contention in this example. And then I print out the number of writes I've made to the database. The reader connects to the database. I spin up 8 workers, which will either perform a standard query, i.e. no follower reads, or will perform a bounded staleness follower read. And I've got a checkbox that I'll toggle follower reads on and off with. Let's create the infrastructure. I'll spin up Docker Compose, where I've got a 3-node CockroachDB cluster with HA proxy in front of it. I'll initialize the cluster. I'll wait for it to become available. I'll enable enterprise features because follower reads are an enterprise feature, and then I'll hop on to the terminal. I'll create my table. This is the salary table. It has an ID, company, state, title, and salary. I'm creating an index on the state column and storing the salary value just to keep reads as fast as possible. Now I'll monitor the number of contended queries that I see by running a query against crdb internal.cluster contended tables. And initially there's no contention, so we're not going to see any values at all. Now I'll start the writer. And over in the console, we can see that writes are occurring. We're making around 100 writes per second. We'll also see that the 99th percentile latency will settle. I'll come back in about 5 minutes, and then I'll turn on the reader. Notice also that in this period, I wouldn't expect to see any contention from the salary table. There might be contention in other tables, but the salary table, there won't be anything. I'll leave that running, and I'll be back in 5 minutes. Right, what we're seeing is 99th percentile latencies of around the 20 millisecond mark. And as expected, there's 0 contention in that period that I ran just the writer. Now I'll run the reader and note that follower reads are currently disabled. I'll let that run for another 5 minutes and then we'll see what the latency looks like then. 5 minutes later, we can see that the 99th percentile latency has increased from around the 25 millisecond mark to around 60 milliseconds. Don't forget, this is the 99th percentile latency. We're seeing a bunch of contention events now, which coincide with the time that I started the reader. This is because the reader is looking for salaries within the 3 states that we're also writing to. So there's contention for data for those 3 states. That can also be seen with our long-running query. The number of contention events is steadily increasing at a rate of around 1 to 2 per second. I'll now enable follower reads, come back in 5 minutes, and we'll see how that's affected the 99th percentile latency. With follower reads enabled, we've seen a noticeable reduction in P99 latency, and we've also eliminated the contention against the salary table. The number of contention events is staying steady, and it hasn't budged from the number that we left it at when we switched to follower reads. Follower reads are worth considering if you operate in a read-heavy environment where you can tolerate some staleness in your data, around 4 seconds. They're also great if you're experiencing contention in your workloads. Have a look at the docs, which we'll link in the description, and see if they could work for you.